Algebra 1, Chapter 7, Section 2, Division Properties of Exponents. So the last section we talked about multiplication properties. Now we're going to talk about division properties. And the way we need to first kind of look at this is with some basic examples. Like let's take 2 to the 5th over 2 cubed. Now, 2 to the 5th means 2 times itself 5 times. 2 cubed means 2 times itself 3 times. Now if you notice here, whenever you have a number divided by itself, like 2 divided by 2, it cancels out and becomes a 1. So we can pair these things off. One from the top, one from the bottom, one from the top, one from the bottom, one from the top, one from the bottom. I'm out of them on the bottom, so all I have left is 2 to the second power. Well, if you notice, there's a shortcut for that, and that is actually the quotient of powers rule. So if I have two numbers of the same base, like x to the 7th over x to the 4th, both the bases are x, I can simplify it by taking the power of the numerator and subtracting the power of the denominator. 7 minus 4 is x cubed. All right. Example number 1. A very important thing here with the variables is you have to assume that no denominators equal 0, because you're not allowed to divide by 0, so that's a problem if you do. So you just assume that they don't for these ones. If you notice, I have two bases, g and h. So all I have to do is take g cubed h to the 5th over g to the 1 h squared, and I write the two bases, g and h, and their exponents become the power of the numerator subtract the power of the denominator. The power of the numerator subtract the power of the denominator. 3 minus 1 is 2, so I have g squared. H to the 5 minus 2 is h cubed.